Hello, this is Mr. Best. Welcome to homework questions 319 to 3-24. 319 wants to know which of the expressions below are equivalent to 16x to the 8th power. Make sure you find all the correct answers. I think the easiest way to deal with this one is just to simplify A through F and see which ones match up. So here we go. On A, you have 16x to the 4th raised to the 2nd. So if we expand this out, I think we can see right away this is not going to equal 16x to the 8th. We got 16 times 16, which is 256, and then x to the 4th times x to the 4th. That's a total of 8 x's. So A does not equal 16x to the 8th. So let's try B. Alright, on B we have 8 times x times 2 times x times x 6 times. Don't necessarily need to expand it out, but you can see it better this way. So we got 8 times 2 is 16, and then 1, 2, 3, 4, 5, 6, 7, 8 x's. So 16x to the 8th power. So it does look like B will equal that. On to C, we have 2x squared times itself 4 times. And so that's 2 times 2 times 2 times 2, which is 16. And then x squared times x squared times x squared times x squared gives you a total of 2, 4, 6, 8 x's. So C is also a correct answer. Now on to D. We have 4x to the 4th power times itself twice. So 4 times 4 is 16, and then x to the 4th times x to the 4th. You can add the exponents and get 8. So once again, D is another possibility. Let's try E. We have 2x to the 4th 4 times. So 2 times 2 times 2 times 2 once again is 16, same as C. But then the difference on C and E is it's x to the 4th times x to the 4th times x to the 4th times x to the 4th. So that's a total of 16 x's. So E is not equivalent. And then the last one we have is F. We have 1/16 x raised to the -8th, all raised to the -1. So remember, when it's raised to the -1, remember how to simplify that. So it's going to look a little crazy here, but 1 over all of this, 1 over 16 x to the -8th. Okay, and then we know that a negative exponent we can rewrite as x to the +8. We have to move it to from the denominator to the numerator. But then we still have that 1/16 on the bottom. So if we write this as x to the 8th over 1 divided by 1/16, that's the same thing as x to the 8th over 1 times its reciprocal, 16 over 1. So 16 x to the 8th power. So it is equivalent to what was given to us. And maybe you simplified that one a little different, but in the end it should simplify to 16x to the 8th power. So to make sure we've answered that question, which of the expressions below are equivalent? So B's expression, C, D, and F are equal to or equivalent. (16x to the 8th power. Alright, question 320. Rewrite each expression below without negative or 0 exponents. So 4 to the negative 1 would be 1 over 4 to the positive 1, which is 1/4. 7 to the 0 is equal 1. So this top one, those are equivalent. On C, 5 to the negative 2 is equivalent to 1 over 5 to the positive 2, which we could simplify if we wanted to. So 1 over 25. And then D, x to the negative 2, same thing as C, but just a variable, be 1 over x squared. So remember, with negative exponents, we move them to the numerator or denominator depending on where they're located, and then powers of 0 are equal to 1. Alright, on to 321. We're going to simplify and solve each equation below for x. So let's start with A, and we got 3x minus 7 is equal to 2. So we only have one variable term, so we're going to add the 7 to the other side. Excuse me. Divide by 3. And x is equal to 3. 9 divided by 3 is 3. Alright, on to B. 1 plus 2x minus x is equal to x minus 5 plus x. So with these, we want to combine our like terms on each side. So on the left side, we have plus 2x minus x. And then on the right side, we have the x and the plus x. So if we combine, we get 1 plus x, because that's 2 minus 1. And then 1x plus 1x is 2x minus 5. So now we can get the variables on one side. So I'm going to subtract x. You could subtract 2x if you want to, but I'm going to subtract x from the left and the right. So I get 1 is equal to 2 minus 1x is x minus 5. And then I can add 5 to both sides. Once again, this is not the only way you can solve these equations. X is equal to 6. And then remember, if we wanted to check our work, we would plug them back in for the values of x. And then simplify both sides of the equation to see that they are equivalent. On C, we have 3 minus 2x is equal to 2x minus 5. So the left and right are already simplified, so I'm going to go ahead and add 2x to both sides. So that gives me 3 is equal to 4x minus 5. Then we want to add our constant. 8 is equal to 4x. And then now, since we're multiplying 4 times x, we divide to undo it. And 2 is equal to x, or x is equal to 2. And then the last one we have is D. And D, we have 3 plus 2x minus the quantity, x plus 1, is equal to 3x minus 6. So with this part right here, with the negative in front of the, or the subtraction in front of the distributive, or pardon me, in front of the parenthesis, we need to distribute the subtraction sign. So it'd be like a minus 1 there. So we distribute the negative 1. So it'd be minus 1x, and then minus 1. And then we want to go ahead and combine our like terms. We have the x's we can combine. And then we also have the 3 and the minus 1. So we have 2 minus 1 is just x, and then 3 minus 1 is positive 2. And so then I'll subtract x. That gives me 2 is equal to 2x minus 6. Add the 6 to both sides. 8 is equal to 2x divided by 2. So 4 is equal to x, or x is equal to 4. And those are your problems for solving each of the equations above. 3-22 for the line graph at the right. We're going to determine the slope and find the equation of the line. So, find the slope or determine the slope. We could find 2 points where it intersects nicely. Alright, and we can use our slope triangle. Now pay attention because these go up by 1, 2, 4, 6. Same thing with the y-axis. So really, when I go down here, this is 1, 2. So that's 2 units down. So that's a -2. And then 1, 2, 3, 4, 5, 6. So that's 6 units. So we got delta y over delta x. So delta y over delta x. So delta y is -2 over delta x is 6. So my slope is equal to -1/3. So that is my slope of the line, -1/3. And then B, find the equation of the line. Well, we can see that the y-intercept intersects at 0, -2. And since we just found the slope, we have the y-intercept and the slope, the starting value and the growth rate. So we now have enough information to write the equation of the line. Y is equal to m, which is -1/3 x. And then the y-intercept's y-coordinate is -2. So y is equal to -1/3 x minus 2. Alright, on 3-23, write and solve an equation to represent the given situation. Be sure to define your variable, so make sure you define what it is that you don't know. Samantha currently has $1,500 in the bank and is spending $35 per week. How many weeks will it take? How many weeks will it take until her account is worth $915? So what is our unknown? We don't know how many weeks there are. So let W equal the number of weeks, or X, or whatever variable you chose. Now we want to write an equation and then solve it. So let's see what we have here. She currently has $1,500 in the bank and is spending $35 per week. Okay, so she starts with $1,500. She's spending $35 per week. So we are going to subtract 35 times the number of weeks that she is spending the money. And then how many weeks will it take until her account is worth $915? So it's at $1,500. We're going to subtract $35 every week. And then when will it equal or be down to $915 in the bank account? So there's our equation. Now let's go ahead and solve it. Let's subtract 1,500 to both sides. So that's -35W is equal to that would be 585, -585. Divide by -35. So W is equal to 16.71. Alright, and that goes on. That's just an approximation. So how many weeks will it take until her account is worth only $915? So at 16 weeks, it'll still be above that. So how many weeks will it take? It'll take 17 weeks until her account is worth only $915. So 17 weeks. Alright, and our last one here, we have 3-24. Determine the equation of the line containing the points given in the table below. Now this is a problem that we did back in Chapter 2, but we didn't test on it in Chapter 2, so this is something that we're potentially looking at for a Chapter 3 as one of our checkpoints. So determine the equation of the line. Well, we need the starting value, which we don't have, and we need the slope or the growth rate, which we don't have. So I think we need to start with the growth rate. So pick any 2 points and figure out what the slope is. And there's a couple ways you guys can do this, but I'm going to pick the last 2 points since they're both positive. So that'd be 2, 5. and 3 comma 8. And so my slope is the change of y over the change of x. So we have 8 minus 5, 3 minus 2. So 3 over 1 is 3. So we know the slope is 3. Some of you might have looked at it like this, where you're adding 1 each time, as long as it's constant. And then this, now you look at your y value, and excuse me, you're adding 3 each time. Oh wait, nope, I made a mistake. Negative 1 to 2 is not 1. So we'll skip that one and then go 5 to 8. You can see that it's also plus 3. And that's what I said. So there you go. You have to be careful when you have a table. They don't always go up by that constant rate. So pay attention. You might have to do what I did down here with the slope formula. So now we have the slope. We need to find the starting value, or the y-intercept. So we will go to our equation. Y equals mx plus b. We have 4 points we can use. I'm going to choose the point 2,5. And now we have our slope, which is at 3. I'm going to plug in all the information I know. Y is 5, slope is 3, x is 2, plus b. Now, you might be wondering, can I pick any of the 4 points? And yes, you can. It doesn't matter because they're all on the same line. So we get 5 equals 6 plus b. Subtract 6 because we're solving for b, which is your y-intercept. So b is equal to negative 1. So now we have slope and our y-intercept. So we can write the equation of the line. Y is equal to 3x minus 1. And if I want to check, I can take all the points in the table and plug them in and see that they work. So for example, I could say on the first point, negative 2, negative 7. I could say, is negative 7 equal to 3 times negative 2 minus 1? Well, negative 7 is equal to negative 6 minus 1, so negative 7 is equal to negative 7. So that does work. You could take the point negative 1, 4, negative 1, negative 4, and do the same thing. Negative 4 is equal to 3 times negative 1 minus 1. So negative 4 is equal to negative 3 minus 1, or negative 4 is equal to negative 4. And there you go again. So each of these points you should be able to plug back into the equation and get an equivalent statement on the left and the right side.